Today, we're going to talk about gluing up plates, and I'm going to demonstrate that for you. I like to use one-piece plates when I can. I think it's cool when you can get a big enough piece of wood, like this piece of butternut, and it has a story to it that's unique, and that you can only get with a single piece back. But often wood isn't available in the quality or size to make a one-piece back, so most often we join both the backs and the tops with a center seam. And the problem with doing that on a carved plate is that when we start out, of course, the material tends to be quite thick. So here's a blank for a top, and you can see it's thicker than I need it, really. And then a lot of material is carved away from the outside, mostly around the edges. And then on the inside, a lot of material, of course, is carved out from the center. So it's not a very balanced way of cutting. And the result is that the parts, after you rough carve them, the parts want to respond by changing shape a little bit so that this surface on the bottom that you made flat when you began the project is no longer flat. So maybe the wood is smiling up like this, or maybe sometimes it distorts in an uneven way. At any rate, what we want to make sure is that that kind of distortion happens while it's still a plate and before it's part of a guitar. Because after it's part of a guitar, if it moves around, it's probably going to crack. Now, in modern builders have a lot of control over the humidity and somewhat less important, the temperature of our work environments. Humidity is really the key. I just looked up the average humidity in New York City. Varies month to month a little bit, but not much. It's between 72 and 76%. So of course, a famous John D'Angelico, our hero, heroic guitar maker from the 30s, 40s, 50s, and early 60s, had his shop down there, downtown Manhattan, with no dehumidifiers, obviously no air conditioners. So he just had ambient moisture, and he had a lot of problems with cracking as a result. Because if you build a guitar at 70-something% moisture, relative humidity, and then you send it out into the world and it goes to someone's home and they have a furnace and it gets cold outside, well, the humidity is not going to be anywhere near the 70s, and the guitars will get stressed and a lot of them will crack. One of the things that John D'Angelico decided to do was he glued either one or two pieces of wood like this to the tops of his guitars on the inside here and here. And you can see I've made up this little dummy. I mean, I've seen a bunch of these in his guitars over the years. Not all of them are quite as large as this, but some of them are. So you can think of these as little cross-grained spruce pillows, which he was using to try and hold the guitar together at the ends. It's probably not a good idea, and it probably doesn't even work very well. But I would resist gluing a big piece of material like this to a guitar top or back. Anyway, so what I like to do, well, first of all, is to keep the relative humidity in the shop year-round the same, about 45% plus or minus a few percent relative humidity. But the other thing that I like to do is to glue the two pieces of wood together twice. So I glue it together when they're rough wedges like this, with a piece of craft paper. So I use a piece of thin, it's basically like a lightweight paper bag craft paper, and I glue that in between the two parts. You can see it here, maybe. Maybe it's easier to see on this tree guitar back here. See that line? So what that does is it means that the two parts are glued together well enough to do the rough carving. And on this plate, for example, or this one too, you can see that the inside has some rough carving marks on it that come off my duplicating machine. You can see, there's some tooling marks here. So the order for these parts is I glue them up with a craft paper, carve the outside, and then sand the outside. Then I flip it over and I carve the inside. And I just keep on working with it with this craft paper in the joint until either the craft paper fails or I've done a bunch of work and it's time to glue the part together without the craft paper. So what the purpose of the craft paper is that if the guitar wants to move, if the wood is going to distort and open at the ends, as it often does, tries to crack at the ends, it's the paper that will fail, not the wood. So you get paper failure, but not wood failure. Now, the ultimate glue for instrument making, or really making anything out of wood, is hot protein glue, animal glue, hide glue, whatever you like to call it. It's basically gelatin. It's the same thing as the material that makes Jell-O, and it's rendered from mammals or fish, I guess, sometimes fish. So these are two parts here that are glued with hide glue, and it's almost impossible. In fact, the glue line is not visible. It just disappears. And hot glue or protein glue is the only glue that makes a truly invisible glue joint. Not only that, it is an incredibly great bonding agent, and it's as strong as it needs to be. So things that have been glued together with animal glue include, for example, most of the pipe organs in the world, all the furniture from ancient Egypt that is preserved in the pyramids and tombs. This stuff really is a great adhesive. It hangs in there. Now, I like to use the 192 gram strength clarified hide glue, which seems to be the same adhesive that the violin makers favor. It's not the strongest grade, but it's plenty strong enough. It makes a bond that's stronger than the wood, and it's an amazing, amazing adhesive. So I'm going to show you how I get ready to re-glue, glue for the second time. We're going to glue this back here for a tree guitar, and first thing we'll do is we'll split apart this paper joint. All right, so here we are. We're gonna plane this joint. First, of course, we have to take this apart. So I'm gonna just stress this center joint a little bit, and I see it's starting to open there. So, of course, we're hoping that we get 100% paper failure, which looks like we did. So, oh, it looks like I came up a little bit short on the paper for here, but there's no wood failure, so we're good. Now, next step is we want to be able to grab each side of the plate and get a shot at it with our nice number 8 plane. So clamp this guy down. And okay. So this board is nice and flat. Of course, this is called a granite surface plate. This is perfectly flat as things get, really. Great thing to have in the shop. This is a perfect size for a guitar maker, 1.5 feet by 2 feet. And then this is a 2 foot long plane. This is a number 8 jointer plane, an oldie. And I have 2 of these. So we're gonna cut like this, and this is called shooting when you use a plane like this, referring to a flat surface. We're gonna shoot this, and this plane we're gonna use to remove the craft paper and whatever little bits of Tite-Bond glue might still be stuck in the wood. I have just sharpened these both for this job, and I'm looking for a chip. That sounds like a cut. Okay, we're planing away the paper and the glue. All right, so we could tell by the sound that was a nice cut that went all the way along. So we're good with this plane. So we've removed the paper and the yellow glue, which is a little abrasive. So now we come back in with this plane, same tool really, but it's this one we're going to set finer, and this job is just to cut the mahogany, clean mahogany. So we'll set this for a very small cut. Okay, well that's a good sound, and you can see the shavings we're getting are very, very small, very thin shavings. So we'll leave it there. Feels perfect. Surface comes out like glass, really. So the right technique for this job is to try and get your plane to cut in the center of the part. So you start out planing from here to here, then from here to here, here to here, etc., till you get the whole part, and you can hear it. You can hear where it's cutting. And so again, the technique is to try and cut in the middle and so on out to the end. Then for the last cleanup cut, the final cut, we want to hear the shaving go from end to end. But we want to make sure that when we take that shaving, we're squeezing the plane into the wood as hard as we can, really. And so what happens is, believe it or not, it bends this long piece of iron into this hollow shape that we've cut. And it's, I don't want to overstate this, it's only hollow by maybe the thickness of your hair. But still, it'll be a little bit hollow in the center, and that's the correct shape for a glue joint. It's also called a spring joint because when it comes together, you have to clamp it in the middle to get the whole thing to touch. It can only be a tiny curve, but it is the proper shape for a glue joint like this. So here we go. So we heard the cut go from end to end, and we believe that we're done with this half. So that's that. So now this thing flips over. Some of you may be admiring these black knobs I've got here. And these are a real cool trick. These are available from MSC or your favorite machine shop supplier. And they come in bags of 100. And all you have to do is just put them in a vise and squeeze them onto a socket head cap screw. And so you can make any screw you want into a knurled screw like this, which are really fun to operate. So you don't have to use an Allen wrench for light duty clamping like this. Inside these holes is a threaded brass insert that just a nice way to handle this kind of tool. So these can be addressed from either side, of course, and makes the whole thing pretty simple. So again, I can't say too much how important it is to learn how to use hide glue for important instrument work. It is the traditional adhesive, and as it turns out, it really, in many ways, it hasn't been equaled, let alone improved, by the modern wood glues. I know that Titebond is, it's cheap, it's easy to use, almost everybody uses it for construction. The only place I use it on my guitar is here, and there it gets, removed. So there isn't one joint in my finished guitar that's held with Titebond. I don't like it because it's, the glue joints are thick and visible to fussy people like me. Also, the adhesive has a lot of solids in it, kind of made from milk. The casein glue that became Titebond, that whole family is kind of a dairy product, and so there's big fat proteins and solids in there, and there isn't a lot to recommend it for instrument work. Not an easy thing to get apart, whereas hide glue, although you can make too much of it, it's not easy to get a hide glue joint apart, but it's possible. You need some skill and practice. Okay, back to the roughing plane. To remove our paper. And this, if you can see here, it's just cut. There's paper here and paper here. So this part is showing evidence of distorting in this unwanted direction. In other words, it's possible that this part, if we hadn't taken the care to let it stress relieve like this, that it would have cracked at the ends. And you can see it's still showing that this is falling off over here. So that's not good. Of course, we're cutting that part out, making it perfect. But this is a good example of, what can happen if you don't do this. You could see it already had this idea that it was going to come apart at the ends. Okay, once again, we've heard it cut all the way from one end to the other. And there's no more paper in there. So we're ready to go to the workbench and have a look at it, dry clamp it, make sure we like it, and then we'll glue it together with hide glue. So here we are, and I've put the clamps on the plate just to check it. And so I'm using 4 clamps, a little more on that in a moment. And I'm looking at it very closely, every which way, to make sure that there isn't the slightest gap anywhere, which there doesn't seem to be. Okay, I can't see any problem at all with this, which is typical. I don't normally have problems with this. The nice thing about the method that we just demonstrated is that, it's a great process and it works. So I'm going to show you a little bit about these clamps. These 2 at the end come from the violin world, and although these would be more of a size for a cello maker. But I made these myself in the machine shop because I just can't help myself somehow. Anyway, so the idea, of course, is that it clamps onto each side and then draws them together with this screw, okay? And so those are called edge clamps. Now, these are called strap clamps. And the way these work, of course, is to grab the plate by the edge with this hook over here, steel hook. And then over here we have a chunk of plastic and a knob to apply pressure. So that's pretty straightforward. Of course, this one goes on the outside, so it's easy to address the guitar with this clamp. But on the waist, it's a different story. You've got to put the clamp on there, and then you've got to slide this guy on there. And then look at all the way this screw has to travel from here to there. in order to tighten it up. And that's just too much time. So one of the challenges with hot glue is that you've got to get the parts clamped together quickly. You have maybe 90 seconds to do it. So you have to plan properly, and you have to get the clamps on efficiently. So I employed a cool old toolmaker's trick, which you can see that's not a round hole, is it? And neither is that a round hole. So what happens is you tap, when you make this part, you tap the hole the normal way so that it just looks like this. And I mean, I did this in my milling machine, but you could do it with a file, just a chainsaw file that you get at the hardware store. Then you cut through diagonally, so that what ends up happening is you have the ability to slide this down the thread, but then when it gets straightened out by the clamp, it picks up the thread on both sides. So it's a quick system. Make sense? Anyway, that's how that works. So I made all of these tools, again, because I can't help myself, but you can buy similar ones. And this is a trick that works on all kinds of things. So, and then just a few more things before it all goes together. These you can get on online. This is just a utility syringe that I'm going to pick up and dispense the glue with. And then, of course, my favorite little acid brush. These cost a nickel or something like that, and they're too long for most of the things I do, but that's easy to fix. You just go like this, and you have the right length brush. So I guess we're ready to set this up and glue it. So I have the glue sitting at about 155 Fahrenheit. There's an idea that you can get hot glue too hot and spoil it, and I'm sure that's true. But it seems to me like they probably have to boil it in order to make it. So it seems hard to understand how getting it a few degrees too hot could really be that bad, which I don't think it is. Nevertheless, seems to be, 145, 155 seems to be the kind of temperature that most people feel is correct for using this particular adhesive. Again, it's 192 grams clarified, which means that they took some of the extra dirt out of it when they made it, so that it looks better. All right, so here we are, clamped with the end clamps, and the next thing we'll do is open them. Isn't that handy? And then we're going to take a piece of masking tape like that. So it's time to glue. And I have the high glue here in my crock pot. And if you want, you can start timing us. Okay, so. moving it around a little bit, make sure it's lining up best we can. Clean up a little bit. It's important not to clean up with water right now because you'll change the shape of the material in a way that you won't be happy with. Okay. And you can see we got glue squeeze out all along, which is just what we want. And that's it. So that's how that works. We expect this to never come apart.